Hello, and welcome to today's webinar, which is in part a status update on TryAPL.org, but also a little look at how you might use Jupyter Notebooks in an education or training environment. If you're watching on Dyalog.tv, there's a chat at the bottom of the screen where you can interact. It's moderated. That's live now, and also the beginning of the presentation is actually a Jupyter Notebook running inside TryAPL. So if you'd like to follow along, you can go to github.com/rikedyp/Jupyter Notebooks. Find this GitHub page, find the notebook titled TryAPL The Next Generation. You can copy that link. You can then go to tryapl.org, the Learn tab, and there's a box at the bottom where you can paste that URL and run the notebook yourself. Also feel free to give questions in the chat session, which I'll answer perhaps throughout or at the end of the webinar. So TryAPL is an online environment where people finding APL for the first time can try the language out at no cost and without having to install or download anything. You can also share interactive code samples quite easily. It was launched in 2012, inspired by Joel Huff's talk when he won the student competition in 2011, and he said that other programming languages at the time had these online try me type environments like trypython.org or tryhaskell.org, but at the time no such thing existed for APL. So in the year following, it was rapidly developed by Brian Becker and the APL Tools Group and has been running ever since. Brian also has a user meeting talk from 2012 where he explains the story of the origin of TryAPL in a bit more detail. John Scholes, who invented the defunds language and sadly passed away earlier this year, was an early contributor and tester of TryAPL. And thanks to John, you can find life in TryAPL. You don't even have to look that hard. Now the system is running on the Dyalog MyServer web server framework, and thanks to the automation server Jenkins, we have continuous integration, meaning that when updates are pushed to the site usually only goes down for maybe a few seconds as the old version is taken down and the new version is put up. And because of this, TryAPL has been running almost non-stop for over 7 years now. The overall look has pretty much stayed the same since its inception, but there are some notable new changes. For example, the keyboard has a sort of updated look, looks a bit more modern and slick, has larger symbols than it used to. There are other things worth talking about, like this center bar here can be used to resize your window panes, which is quite convenient. Also, the tooltips in the primer can be dragged around. When you hover over, you get an explanation of what a primitive does. You can drag these around to your convenience. And another quite nice feature is that you can click on the code samples and enter them directly into the session without copying or pasting or typing anything in, which is quite nice. You can also generate hyperlinks for your one-liners. When you hover over an executed piece of code, this link icon appears and you can click that to get this encoded URL. You could use a URL shortener or something, but you essentially can paste this into your instant messenger or Twitter or other social media, share your code with other people who may not necessarily have immediate access to an interpreter, and they can try the code there and then. TryAPL also has a special version of the help user command. You'll notice I switched tabs then to show you the primer, because at the moment, if I change to one of these tabs while I'm running a tutorial, I'll lose my place in the tutorial, unfortunately. But with the help command, I can find help on any of the APL primitive functions by typing help and the function symbol. It will then paste the tooltip text right into the session. TryAPL now sports a version 16 interpreter, so you get the latest primitives like nest, partitioning close, where or interval index, There's the stencil operator and the @ operator, and if you want to know what those do, just type help @ there's the tooltip. There's more functionality as well than there used to be. We can now safely execute, well, we can use execute to convert character vectors into numbers, numeric types. We can also use format to convert from numeric types into character vectors. We also have the 819 iBar available, which is for changing the case of some text. But if you find that a bit strange to type, you can also copy L-case and U-case, which would change the case of text there from the dfunds library. And as you saw, and here you can see, all of the lessons and tutorials on TryAPL are now Jupyter Notebooks, which are hosted on GitHub. What I like about this format, one of the things, is that you can have your explanations sequentially or interweaved with your code examples and get deeper, longer explanations to more substantial code than perhaps, well, you could from having a one-liner with a comment at the end or something like that. Here is just a simple example of the grade primitive explaining how you can do array-based indexing, and grade gives you the indices of a sorted array with which you can sort a different array. That's just a simple example. Not only could you give explanations like this, but one idea is that you could give problem sets that are interactive. So you could have your test cases in the notebook set as variables. You can then ask your questions, like in this example, I have a nested array here. How do I, with a single multiplication on that nested array, how do I get this result? Your students could then go into the session, they could try out their ideas. How close am I here? It's along the right lines, but I'm not quite there. I give up, so I'm going to get the answer. I should have nested my other argument. Okay, so that's the type of thing that you can do with Jupyter Notebooks. And with TryAPL, you don't even have to have Jupyter installed or APL installed. You can just run it straight like this in a web browser. So you can explain your things more clearly, you can give longer explanations, and you can also build up your explanations, scaffolding on top of students' existing knowledge. So here's a sort of trivial example of that. Everyone knows how to add numbers. Say I want to add a load of numbers. Well, in APL, that is incredibly trivial. Using the reduction operator, the plus reduction of all these numbers gives me the sum. And also, I don't even have to type out the numbers. Much better. Also, you can render emojis thanks to Unicode, which is quite cute. So there are several ways to create and interact with Jupyter Notebooks. The previous webinar by Dyalog APL tells you how to install Jupyter Notebooks with Anaconda. That's quite a large package for data science, so you don't necessarily have to use Anaconda, although some things I think it makes a bit more straightforward. But you can also use the Python package manager pip, and then you can get Jupyter installed with a much lower footprint. There's also two other things I want to talk about, JupyterLab and JupiterHub. So JupiterHub is a multi-user version of Jupyter Notebooks. So you could imagine setting this up in your classroom or institution. You set up a server and it runs as a web server. You can then create user accounts for your students or people participating in your course, and then they can go in and have maybe access to a centralized set of pre-made notebooks explaining your course, and then they can interact with those with their user accounts and modify things or answer examples, sample set, problem sets, and submit work that way. Now, due to technical issues, I couldn't get a nice JupyterHub demo working, but I have something in the same vein using JupyterLab. JupyterLab is just the new user interface that goes on top of Jupyter Notebooks. So I have the Anaconda version installed. I'm going to run that. in the Anaconda prompt, I can go to a certain directory, and when I type Jupyter Lab, the system will run from inside that directory. So you can see that I have these pre-made notebooks here. One of the nice things that you can do in this instance is you could set up your IP address and port forwarding so other people can access this server. And then Jupyter Lab allows you to actually have a console as well as just the notebooks. So this console is running the Dyalog APL kernel, and I can execute APL code in here. And if I wanted to, I could have my students around the room go. I'm going to simulate this by opening another window and copying the URL in. I've also set up a password for my, guess what that password is, for my Jupyter server. So then students around the classroom could log in, and then they could, for example, access this same session. Is this the same session? I believe it is. So then I can set variables in my session, and the students could pick it up at the other end. I can even create trad funds or defunds. So here's just a trivial one as well. Maybe it does that. Maybe it sums up its argument. And around the room, everyone has access to this. I think it's quite easy to see how this could be problematic in some circumstances. This particular example has a few flaws I'll talk about. I think you need to trust your students a fair amount to not mess around with your notebooks here, but you could do something like, for example, I have a problem set here with space for students to answer, and you could do something like create a new folder. We could name it something like student submissions, if I can type. And then you could have your students copy the notebook into that folder and rename it, for example. With the JupiterHub system, I think it would be more straightforward when you have independent users. But this sort of gives you a flavor of what I mean. But yeah, you need to trust your students enough to not go and mess with other students' notebooks, etc., for example. One last thing I'm going to talk about is one of these notebooks I have prepared. It's Joseph Fourier's birthday, coincidentally, today, and this notebook was prepared beforehand, and it's about creating sawtooth and square waves with Fourier series. So for students here, I've set up some terms. Thanks to the fact that APL has no reserved keywords, I can just rename the functions to convenient things for my purposes. So I've created a sine function with one jot circle, and pi I'll have to put a number on the right of pi to get a multiple of pi. This cell here contains LaTeX equations, and they get rendered quite nicely in Jupyter Notebooks. So we have the traditional maths notation here, and you can see how easy it is to transform mathematical formulae into APL. So here are the examples from here, from the Fourier series. And then here's some ways that you could graph these functions up. So we have our sum of integers, in the sawtooth case, n1 to infinity, and square wave you just get the odd ones. So here I just have the index generator. Then this function will create the numbers reciprocal omega to alpha times pi, and this is a little bit dense, in steps of reciprocal omega. That's just a way of creating my x values. As you can see, this example here, x is 1/100th to 2 pi in steps of size 1/100th. And then this translation of the formula is fairly direct. So we have reciprocal of n times the sine of n times pi times x, where n is in this case 1 to 5. So you have your students do shift enter to execute all of these cells in order. We can also initialize the sharp plotting library of Dyalog APL inside the notebooks. have a nice little wrapper plot function. You could also intersperse your explanation with some basic examples to help bring people up to the understanding you want them to have at the end. So in this example, I've got these sums for integers, and I want the students to be able to create the vector of integers. So use the index generator basically, and then how to create odd numbers. Well, it's 2 brackets n minus 1, or minus 1 plus 2 times iota n. And then you could have something like this where you have a pre-made example and you just want students to modify the codes. This is a simple example I've come up with. So you can see how adding a number of terms creates a sort of more refined wave. So this is the sawtooth wave, and as I add a number of terms, I get a much neater version. And you can also ask how to change it to a square wave. Well, what we asked before should give them a clue. Here we just change the terms to be odd numbered terms only, and miraculously I can plot a square wave. The reason I also bring up this notebook is it shows some of the limitations of TryAPL as an interpreter. So if I just copy the sharp plot notebook and paste it into TryAPL, most of the cells execute like normal because it's just simple markdown and APL code, but anything with the LaTeX can't be rendered, and also you're unable to use sharp plot inside TryAPL. So I think, are there questions now? If there are some, I'll be happy to answer any. Otherwise, I will sort of conclude and wrap up. So while we're waiting for questions, I'll just say that TryAPL, you should show your friends. It's really good for sharing one-liners because you can just have a URL encoded that will take them straight to APL and run the code there and then. If you have something a bit more substantial that you want to share, upload it to somewhere like GitHub or any web server as a Jupyter Notebook, and you can run it inside TryAPL without anyone having to download and install Jupyter or the APL kernel or Dyalog APL system. And if you're thinking of setting up any type of training or courses where you think this would be useful, have a look at JupiterHub and Jupyter Lab as a way of distributing your course materials and having students able to interact with these course materials. So the next webinar is scheduled for the 18th of April, topic to be decided. With regards to TryAPL, please send your comments and suggestions to tryapl@dyalog.com, and if you create any Jupyter notebooks that you would like to share with us, please submit them to notebooks@dyalog.com. Thanks very much.